Greetings to all. This is Dr. Shakti Mohan. Today we are going to discuss about the content that is the basic introductions of combinational logic circuit, and also we are going to discuss about the half order and full order circuits. That is how to design the half and full order circuits. So we'll see one by one. Okay, so first of all, before entering to the order circuit design, we must know about what is combinational logic circuit about. So generally, I hope you can see the diagram. This is what the logical diagram for the combination. There is a block diagram for the combinational logic circuit. So here we have n input variables and m output variables are there. Okay, so generally, the technical definition for the combinational logic circuits is when all the logic gates are combined together to perform a specific task with the help of some set of inputs, that is n number of inputs it have, and it will deliver m number of output variables, right? So that is what the basic introduction of combinational logic circuit. The major point in the combinational logic circuit is without a memory element involved, the above operation will be performed. That is what combinational logic circuit, right? Okay. So we have a n number of input variables, and in the output we have a m number of output variables, right? Okay. But the major part is without a memory element, right? Okay. See here, I'm just mentioning the points. Okay. So since I already told you, when logic gates are connected together to produce a specified output for certain specified combinations of input variables with no storage element involved. This is what the major point. So the resulting circuit is called combinational logic circuit. Okay. And the next major point in the combinational logic circuit is the output variables are time dependent to the input variable. Okay. So that means the output is only depends on the present inputs, not by the previous inputs. That is what the next point. Okay. Since it doesn't have a memory unit, okay, so it doesn't have a memory unit, so the output is depends only on the present inputs, not by the previous inputs. Okay. So if you consider about a sequential logic circuit means it contains the output which depends on both present input as well as the previous inputs, right? Okay, that is what the major difference between the combinational logic circuit and sequential logic circuit, right? Okay. I hope you can understand the basic introductions about combinational logic circuit. So next we'll go into the order circuit design. Okay, so generally order having two types, that is half order and full order. So the major addition rules is, okay, so the basic addition rule is 0 plus 0 is equal to 0, and 0 plus 1 is equal to 1, and 1 plus 0 is equal to 1, and 1 plus 1 is equal to, actually the answer is 10, and in that 10 the 0 is the sum result and 1 is the carry result. Okay, so 0 is the sum result and 1 is the carry result. That is what the important point. Okay, so this is what the basic addition rule. With the help of this rule only, we are going to design the half order and full order circuit. Okay, so we'll see into the content window. Okay, so see here I'm just mentioning the inputs. Okay, so since I already told you in the order circuit there are two different kind of orders will be there. So one is half order and one is another one is full order. Okay, so since the order having only two inputs means we will use half order. Okay, so if only two inputs na, we are going to use only half order. So in case if you are going to use three inputs na, in that case we are going to use full order. That is what the major difference between half order and full order. Okay, so that means half order having only two inputs and full order having three inputs. Okay, and depends on the input, it contains both half order and full order contains only two outputs now, that is sum and carry. Okay, so these are the two outputs which contain the which the orders contains the output, right? Okay, so first we are going to discuss about the half order circuit. So first of all, I'm just mentioning the block diagram. See here the block diagram of half order, that is half order, and there are two input, that is A and B, and two output, that is sum and carry, right? And this is what the truth table for the half order, very simple. So input here I'm just mentioning A and B. So since it is a 2-bit input, I'm just mentioning the input with the help of 2-1 concept, right? So very simple, 0, 1, 2 and 3. Okay, if it is 0 now, there is no 0 in the 2 1, so both were 0. And 1 now, there is a 1 in the 2 1 concept, So for that one, there is a 1, and for 2, remaining 2, 0 will be there. Okay, so likewise, you got to fill it out the input. Otherwise, very simple method. Since it is a 2-bit combination, 0, 0, 0, 1, 1, 0, and 1, 1 are the combinations of input, right? Okay, and output, sum and carry are the output. Okay, so we already know the addition rule, right? 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, and 1 plus 1 is equal to 10, and 1 plus 0 is equal to 1, right? So with the help of those rules, we are going to fill it out the truth table. See here, 0 plus 0 is equal to sum also 0, carry also 0, right? And 0 plus 1 is equal to sum is equal to 1 and carry is equal to 0. And 1 plus 0 is equal to sum is equal to 1 and carry is equal to 0. And 1 plus 1 is equal to actual result is 10. And in that 10, sum will be 0 and carry will be 1, right? So that is what I'm just mentioning here. Sum will be 0 and carry will be 1. Okay. So after completing the truth table, we are going to put the K map. So why the K map is required now? Because we have to find out the final result for the sum and carry, that is Boolean equation, right? So if you want to find the final equation means, so the K map is the only way. So see, since there is a 2-bit input, so 2 variable K map will be plotted here. Okay, this is for sum and this is for carry. Okay, so 2 K map will be there. So once you completed the K map, so you can get the result that is sum is equal to A XOR B and carry is equal to A into B, right? So for K map, the simplification of K map and use for the Boolean function, we already discussed in the previous videos. So if you want, you can check those videos also. I hope you got the information from that video, right? Okay, so once you got the output result, after that you have to draw the logic diagram, right? So you can see, so the sum is equal to A XOR B and carry is equal to A into B, right? So here I'm just mentioning one XOR gate, one AND gate. With the help of those XOR gate and gate, I'm just implementing the sum and carry output with this diagram, right? So this is what the logic diagram. Okay, so in the combination of logic circuit, so whatever the design you are going to do, the design starts with the block diagram and ends with logic diagram. You can see we just starts with the half orders block diagram and ends with the half orders logic diagram. So this is how we have to design the half order, right? Okay, so the next part is we are going to design the full order. So very simple, according to the addition rule, we are going to design the full order also. Okay, so what is the major difference between half order and full order now? So half order having only 2 input, that is A and B are the inputs, but the full order having 3 input, that is one more input will be there. So here I'm just mentioning, you can see A, B and C in is the one more input and sum and carry is the 2 outputs, right? Okay. So again, according to the addition rule, that is 0 plus 0, 0, 0 plus 1, 1, and 1 plus 0, 1, and 1 plus 1, sum is equal to 0 and carry is equal to 1. According to this principle, you have to fill it out the truth table. Okay, so how to fill it out the truth table? Now it is very simple. First, let me take in this input. First, you have to add this 2, okay, with the addition rule. And once you got the result, so that result will be added with this. Okay, so the final result will be mentioned here. That is sum, you have to mention it here, and carry, you have to mention it here, right? And since this is a 3-bit input, so that we have to follow 4-to-1 concept to fill it out the input, right? Otherwise, it is very simple. 4 zeros, 4 1, double 0, double 1, double 0, double 1, 0 1, 0 1, 0 1, 0 1. Likewise, we have to fill it out. And once you completed the actual truth table, so the next part is you have to make the K map. Okay, K map for find out the final result, that is sum and carry. Okay, so once you simplify the K map, so you can get the sum result as A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C. So likewise, the carry result are A into B plus B into C plus A into C, right? So for that, final logic diagram will be drawn like this. This is for the logic diagram of sum and this is for the logic diagram of carry, right? So this is how you have to complete the full order circuit. And since the sum result is having a huge equation, so with the help of Boolean algebra simplification, so we just reduce the equation into this. That is, the sum is equal to A XOR B XOR C. This is what the explanation for that, right? So we have already discussed about the simplification of Boolean function using Boolean algebra also in our previous video. If you want, you can check it that videos also, right? So once you got the simplified output of sum, the final logic diagram is this. Okay. So for sum is equal to A XOR B XOR C, and for carry is equal to A into B plus B into C plus A into C. So C means C in. Okay. So the another name of carry is C out. Okay. So this is how you have to design the combinational circuit, that is order circuit. So particular that half order and full order. I hope you understand the concept. So in today's video, we have discussed about the basic information about the combinational logic circuit and half and full order design. I hope you understand the concept. Thank you.